Okay, so let's start the first lecture of AI. So the first question is, what is AI? AI is basically the study and design of intelligent agents, where an agent will perceive or it will take some information from its environment and then perform some action which will maximize the chances of success. Okay, so agent is anything which is basically taking information from the environment and then performing some action in the environment, which is going to bring it closer towards some goal, which we will see in a little while. Okay, so before we begin, let's quickly discuss some very basic terminologies which will be used in this course. So first one is going to be this scenario, which I've presented over here, that there is an agent and any information that it's going to percept from the environment is going to be through sensors, which means percept is just saying gathering information from the environment. And to perform any action in the environment or to perform any action by the agent, it will be done using an actuator. So sensors will be used to gather information, get information, and actuators will be used to perform some action. Now, what are some examples of agents? The first example is a human agent, that which is us. We gather information through ears, through nose, through eyes, etc. So through ears, we're taking audio. Through nose, we're taking some sort of smell. Through eyes, we're taking information through vision, right? And the actuators for our human body is going to be hands, legs, and etc. For a robot agent, that would be changed as ears would be now audio sensors, the eyes would be now cameras, and your hands or legs could be mechanical arms or motors, and etc. We can also have software agents, which is like they can take input in the form of keystrokes, in the form of file contents, or like receiving packets over the internet or the network, and they would be displaying the information. This will be the actuators. So displaying information on the screen, the files, and the send packets over the network. You will see that I've used a color coded um, I've done a bit of color coding. So whenever there's green, I'm talking about an agent. Whenever it's blue, so I'm talking about the environment. And whenever I'm talking about actions, I'm talking about actuators. So yeah, now let's talk about what is an agent function. So an agent function is just an agent equals to some agent program plus some architecture. Now agent program basically tells what the agent is going to do, and the architecture is basically telling how the agent will do. Will it do it with using data structures? Will it have some sensors? Will it have some actuators? The necessary hardware and software components required by the agent is going to be in the architecture, and the agent program is just going to be the driver code as to what the agent has to do, and how he has to function with the architecture. So the better the agent program is going to be, the better your performance is going to be, right? Now moving on towards what is types of knowledge and how types of knowledge accessible to an agent. Now I've changed a color coding a little bit, so these colors do not represent agent and environment and red. These are just used so that you could quickly memorize these. So there are three types of knowledge which are accessible to an agent. The first one is rational agents, which is where you're very greedy and the agent basically knows it has the expected output. So what is a rational agent? A rational agent is basically having an optimal path or choice from all the current possibilities, right? It will always choose the optimal path from the current possibilities. And omniscience agent, on the other hand, will have the actual outputs. It has the knowledge of all the possible outputs and actions. The difference between a rational agent and an omniscience agent can be explained using this example. In this very poor example of a car driving scenario where there's a car and it's driving towards some goal and there's a traffic signal in between, and please excuse my very poor drawing skills, but this will thoroughly explain the difference between the rational agent and omniscience agent. So first let's deal with the rational agent. For example, there was this car and the car wanted to go towards some goal and the traffic signal was green. Now, obviously, the car would move, right? But accidentally, what happens is there's a guy who was walking on the crosswalk and there's an accident. And now the car can no longer achieve the goal. So, In this current situation, when there was when the traffic signal was green, the best option for the car was to go. It wasn't to stay. It didn't know that in the future there would be a guy who would be walking on the crosswalk, right? But if it was an omniscience agent, then it would have known that when it's green, there might have been a person who would have been walking on the crosswalk, and it could have avoided that and could have reached the goal much faster and safely. So that's the difference between what's a rational agent and what's an omniscience agent. There's Omniscience agents aren't possible in real life, because when we're talking about large scale AI programs, we don't have enough computation power and we don't have enough memory for that. But in small scale, you can create omniscience agents. Then we have autonomy, and autonomy is basically giving the agent free will. So it basically gives the agent the free will. For example, in this case, if it was green, the car would have could have chosen to like stay. If it was red, it could have chosen to go, but it would learn from its experiences. It has its own free will. We haven't hard coded anything into the agent or in the AI. So those are like the types of knowledge which are accessible to the agent. Now let's move on to how to define an AI model. Now we have some performance P. This any for any AI model we can for any AI model we can define it by using P's, which is P for performance, E for environment, A for actuators, and S for sensors. Now, in a case of a car, right, for an automated car, the performance could be as to how far it's traveling, as to how safe it's being traveled, and how comfortable it is. The environment could be roads, building, people, which are like walking on the road. The actuators could be the motors, the wheels, the steering wheels, the brakes, and the signals. The sensors could be the cameras, GPS, engine sensors, and speedometer. So if you ever want to define an AI model, you would always use P's because it just simplifies it a lot. Now we're going to talk about what are the different environment types, right? So there are different environment types, and I'm going to be explaining it using this small presentation. The first one is like fully observable versus partially observable. So fully observable environment is where the agent where the agent sensors can see all. Okay, my bad. I might have done a little bit of grammatical issues over here, but let's just ignore it. I'm just going to use this one. Okay, so fully observable is just an agent sensor which can always measure all the relevant information in the environment at all times. So um, it's basically a scenario where an agent can see all of the information at all times, right? So nothing is unseen from the agent, right? And partially would be where you cannot see all of the states. You can't see all of the information. For example, in tic-tac-toe, right, you can see the entire board, right, and you can see all of the options available. So tic-tac-toe would be fully observable, and the cards would be partially observable because you can only the agent who's playing the game can only see what he or she or it has in its hand, and it cannot see the rest of the cards. So you can't possibly know the future states. You can't possibly know how the game would turn out. Similarly, if you're like playing Counter-Strike or you're playing any FPS game, you can always see what is in front of you, right? If you're talking about first person, we're always obscured by a certain amount of vision, right? You can't see behind the character. So you, in that case, that would also be partially observable. Now the next one is deterministic versus stochastic. The deterministic is you can determine what the next state of the agent is going to be. State is anything. If I've not discussed what state is, state is basically the current. How would I say, the the what is being happening? What is the current situation? That is what is the state. So you cannot define you can deterministic would be you can determine the next state of an agent, basically, which means there's no uncertainty, right? You're always going to get to the next state. For stochastic, you cannot determine what the next state is going to be, so there's always uncertainty. For example, if this is like a vacuum cleaning service, you can always determine, okay, I can go to A or I can go to B. I can maybe remove this dirt, or I can move to the next I can move to B, right? So every scenario over here is deterministic, but like in a case of like a taxi driver, you can't determine what's going to be the next state, because sometimes you don't know if there's going to be an accident after 5 miles. There can be an accident after 10 miles. You don't know if there is going to be a car who's going to be approaching you. You can't determine anything, so there's always going to be some sort of uncertainty while you're driving a car. But in this case, in a case of a vacuum cleaning service, or vacuum cleaning robot, this can determine what the next state is going to be. The next is episodic versus sequential. So sequential is basically dependent, which means there could be a consequence or effect on the next state, right? And episodic is independent, so there will never be a consequence or effect on the next state. So for example, there's a car which is like traveling at 100 miles per hour, right? And there's another car which is like traveling in front of it, right? And accidentally the car A like pushes car B, then uh, that's going to affect the other agent, right? So in any scenario where there's going to be an effect, for example, another example I just remembered was in a game of chess, right? There are two players which are playing. So if player A plays some move, that's going to impact, or it's going to bring some effect on the next state of the other agent as well. Episodic is there will never be any effect. So for example, this is a robot which is like just grabbing stuff into a box. So it doesn't matter what object it's going to grab. Its only task is just to grab and just put it in the box. So that would be um, independent. So whenever it's dependent, their dependent task, it will be always be sequential. Whenever it's independent, it's always going to be episodic. Then we have dynamic versus static. Dynamic means if its environment is changing while the agent is thinking. For example, a car, the environment is constantly being changed because you're moving, right? And static is its environment isn't changing. So you can see there's just chessboard and it's not being changed at all. So this is going to be static. And then there's semi-dynamic, which means the performance of an agent changes, but the environment doesn't. For example, if this was a chess match and there was a clock as well, so it would be a semi-dynamic, because now the player has to move very quickly, because now the clock is also measuring the performance of the agent as well, because the faster the agent will move, the more time it will have to think better decisions in the future. But as you can see, the environment is still not changing. So that's the difference between dynamic and static. Then we have continuous versus discrete. Continuous is basically decimal values, something, or we could think of it as like if the agent is being controlled continuously, right? So for example, there's a car which is being controlled continuously. We can never stop this car if it's being if we're assuming that the car is moving on a highway, right? And we want to reach from point A to point B, the car is being controlled continuously, right? That would be continuous. And discrete would be whole numbered, fixed data, steps, or countable. Like anything which is countable, for example, 1 2 3 4 5 6, there's no decimal values, it's always fixed, it's always whole numbered, right? It's always in the form of steps, then it would be discrete environment. Then lastly, we have single agent versus multi-agent. Single agent means one agent, multi-agent means more than one agent. And also there another thing to note is random behavior, right? So for example, let's say that there were two players playing against with each other, and if I would have hard coded every single move that player one would do against player two, then that wouldn't be a multi-agent, because it's not having any random behavior. It's a fixed behavior. So whenever we want random behaviors, multiple random behaviors, we're always talking about multiple multi-agent. So chess is a multi-agent environment, and this is a single agent environment with which you have to like, this is like a puzzle, so only one player is playing this. So there's some key distinguishes key points that you can distinguish if it's fully observable or partially observable. Fully observe Whenever we're talking about partially observable, we're always talking about memory or internal state, because since it has very limited knowledge, or very limited you could say um, information, it always relies on its previous history. So it will, whenever we're talking about some sort of memory where it's looking at its history, we're always talking about partially observable. Um, if you're talking about uncertainty, right, there we're talking about stochastic. If we're talking about dependency, we're always talking about sequential. For dynamic and static, it's always about the environment being changed. For continuous and discrete, it's as to like you have integer, your data is in integer or is it in in floats. In single agent and multi-agent, we're always talking about random behavior. To summarize, there's this exercise. I'm going to pause the video for like, I would say 10 seconds. Or you could pause the video for 10 seconds, right? And then I'm going to show the answers and then we're going to move on. Okay, and these are the answers. Okay, good. So now we have discussed the different types of environment types, right? Um, can like this is like a summary. You can take a screenshot if you want. I've also color coded this. So F for this, E for episodic, and so on and so forth. This is an acronym that I've used to memorize it if you can. Also another thing. If it's going to be, one point that I missed was if it's going to be fully observable, in most cases, it's going to be deterministic, right? Because since you can fully observe the entire environment, so there will never be any uncertainty because you know everything about the environment, right? And if it's partially observable, then it can be stochastic, which means you're like unsure of what's going to be the next case as well. So fully observable and deterministic are like connected a bit. Okay, next let's discuss about different types of agent types. So the first, we're going to be talking about 5 types of agents. The first one is going to be simple reflex. So simple reflex is mostly on if else. And there's this very funny example that I showed of Scooby-Doo, and it's like the entire AI based is based on if then else if. So simple reflex is like if else. So what's going to happen is you're going to perceive the current state of the world and you're going to perform some action based on some conditions. For example, let's say that I have a room which is like it has a temperature of 25 degrees centigrade, and let's say for some reason whenever it's 25 degrees centigrade I want to turn the AC on. So I'm perceiving the current state, which is the current state of my room, the current temperature of my room. The action, the condition that I applied was whenever it's going to be 25 degrees centigrade, I want to perform some action, and that action is going to be to turn on the AC. In these types of simple reflex models, right? If you want to take a deeper dive, so we're always talking about feed forward, which is like just going forward. There's no backtracking. There's no sense of history, right? We're just moving forward. We're just looking at the current state and just performing some action. We're not recording any past history of what we have already done. It also works best for fully observable, because once you know every case, then only then you can like perform some action. But if it's not fully observable, if it's partially observable, then there's a possibility then there could be an infinite loop. For example, let's say I have a Pac-Man game, and I have hard coded that a Pac-Man, the Pac-Man can go left, it can go right, but I didn't code anything about going forward. And there could be a state where it could keep on going left, 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 and it could like find a wall and it could be stuck in an infinite loop. So there could be cases like that. Then we have a model-based reflex, and a model-based is just a simple reflex with some past history. In general, if you're talking about reflex agents, so reflex agents basically perform some action based on the current percept. If it's only the current percept, we're talking about simple reflex. If we're talking about the past history as well, if you're involving the past history as well, then it is a model-based reflex. So it is always considering how the world is, right? So it doesn't takes into account of the consequences of its actions, which has been shown in this very nice picture. Then we have the other types of agents, which are goal-based agents, and that's basically model-based agent plus searching and planning plus goal. So goal-based, as its name states, it will be searching. It will be based on some goal. So how how fast am I approaching a certain goal? How quickly I can reach a particular goal. It's going to be a goal based agent, and it's always going to search and plan. So it is always going to first plan if my current action is basically contributing me to go closer to the goal or not, and I'm going to search if there is a certain path or certain option that can lead me to that option. Then we have utility based, and that's basically gold, and it also adds the functionality of satisfiability, which is if you have multiple alternatives of reaching towards a certain goal, and you have some preferences. For example, let's say I want to get from point A to point B. I can just like draw it over here. Let's say I want to go from point A to point B, and there's this road, there's this road, and there's this road. Let's, for simplicity, let's just keep two roads, and let's say that this road is very uneven, and this road is very smooth. Even though this is the shortest path, but I want to go on a smooth road, so I would choose this road over here. I would choose this path. So this would be then this would be a utility based scenario. Then we have then we, these two can be categorized as planning agents. It always asks what if, right? It is always ensuring the consequences, and also how it's going to impact the entire state uh, of how it's going to impact its future decisions, and it's always going to formulate a goal, right, which is like what I want to do. So it is always considering how the world would be. Now reflex is how the world is, and planning agents or goal based and utility based is how the world would be. Lastly, we have the learning agent. I have taken this quote from Andrew Angie, which is like learning. Any agent which is going to learn from experience E from task T with performance P is going to be a learning agent. So experience comes from in the form of knowledge. Performance can be measured with using feedback or critics. And I've also inserted this thing. There are like different elements to learning agent. The learning element is like it's responsible for making improvements by learning in the environment. The critic is basically telling it's taking feedback and it's describing how well the agent is performing, right? The performance agent is basically telling it's like selecting, in this case it's like selecting an external action, like which action should I choose. And the performance agent over here is just responsible for suggesting actions that you could do this or you could do that, and so on and so forth. So that was all from the first lecture of AI. Hope this helped. And yeah, if you have any questions, feel free to comment down below. Thank you.